All right, we're back. We're still on page 55 of notes 5. Well, not 55 of notes 5. I don't know what page we're on of notes 5. I guess 18 of notes 5, really. But 55 of math analysis, maybe we'll finish. Maybe not. Who knows? So these, we're doing trig equations to go through the data in the table. I think starting with scatter plot's a really good idea, especially in this case where if you look at it, you're just alternating two values. So one thing that could potentially be happening, it'd be like a real jerk move, but what if we only have like the minimum and the sinusoidal axis, right? What if you go up 40 more and you get to 110, that's the maximum. So we want to make sure that what we're seeing fits the pattern that we think we're going to find. So that's why I'm going to definitely make a scatter plot of these. Just going to do it by hand because it doesn't need to be perfect. And we're just trying to get an idea. So let's see. So -6, -3, 0. So we're going by threes. 3, 0, 3, 6, 9, 12, 15. Did I get them all? Yes. Did a much better job spacing that time. So we're going 30, I guess. 70, 30, 70. So I'm feeling pretty confident about what's happening here. Now, so I think I'm seeing the maximums and the minimums because it's not really possible to go over the same amount again. So what I would have to do is from -6 to -3, I go up 40. Then if I go from -3 to 0, I'd have to go up another 40, but I already know where I am at that point. So like I'm not up another 40, I'm actually back down 40. So what we're seeing are the maximums and minimums, which means that we need to somehow, what's going on here? We need to find the sinusoidal axis, which would just be the midpoint. So not a big deal, but it is something you definitely need to think about, right? So I'm going to say add them together, you get 100, divide by 2, you get 50. So it should be that like here, here. So you don't really need to put them all in, but apparently I'm going to. So these are your sinusoidal axis points, and they're all at 50. Right, so maybe this is a weird way to make a graph. 70, 50, and then 30. So from 50, you can go up 20, you can go down 20. Perfect. So we actually know quite a bit already, right? So this is going to be D. So since this distance is 20, that's going to be the absolute value of A. I don't know if I'm going positive or negative until I actually start doing it. And then I know that the period, so from consecutive maximums, let's say. Consecutive maximums be from here to here, which I should probably use a table for that, but that's 6. So I know the period is 6. Period 6, which means that the increment is 6 over 4, so 3/2. And also 2 pi over b is equal to 6, which means that b is pi over 3. So a lot of stuff we know. And now let's get started. So I'm gonna, at -6, I'm definitely starting at a minimum. It's a pretty cramped trig function here. Something like that. All right, -6, definitely starting at a minimum. So let's see. At x equals -6, start at a minimum, so it's negative cosine. Equals, so I'm going to say it's 50 minus 20. Oh my gosh, how is that a 5? 50 minus 20 cosine pi over 3 quantity x minus -6, which is plus 6. And there you go. So now if we go over one increment, so an increment is 3/2, right? So that's -12/2 plus 3/2, -9/2. -9/2. F of x. So you go from negative cosine to, so it's minimum, intercept. Now you go intercept maximum, so positive sine. So it'll be 50 plus 20 sine. And you can at any time just sketch a graph and look at it, which I think is actually a good idea. I just also like to show that we can do it other ways. We're going to add 3/2 again, get to -6/2, which is -3. So -6/2. I'm going to write it that way. All right, so sine goes intercept maximum. So now we're going to start at the maximum. So that's positive cosine. Cosine of, and we can check that one in the table or on the graph and just see that we're getting what we think we're getting. It's just easier if you don't simplify your fractions, right? So at 3, are we at, yeah, at 3, we're starting at maximum, positive cosine. Got it. And then finally, add the increment again to get to negative 3/2. So if we start at a maximum intercept, so now we're going to go intercept minimum, so negative sign. So 50 minus 20 sine of pi over 3 x plus 3/2. And there we go. All right, so that's 4. And that's good. I'm not going to check them. You should probably check them. I'm not going to. I'm going to risk it. Let's see if we can do this. So first thing that I notice, kind of, is that I see 3 different values in the table. And that's good because it usually means that we have all the information that we need, potentially. So I think the minimum is going to be negative 3. The maximum is going to be 2. So let's say minimum negative 3, maximum 2. So the sinusoidal axis halfway between them would be y equals negative 0.5, which makes sense because that's what was given. Now what is happening here? So the easiest one to see is that this is 0.625. And then if you test it, I mean, you can see that they're all 0.625 apart. 625. So 0.625 is what? 5/8, I think. So 1/8 is 0.125 times 5 would be 0.5 plus 0.125. So yeah, 5/8, I'm pretty sure. Which fractions are just easier to work with, which is why I'm doing that. But we don't really need it, I get. Well, other than, so what's the period, right? The period is 4 of these things. So the period is going to be 4 times 5/8. 4 times 5/8, which is 5/2. So 2.5, which if we multiplied 0.625 times 4, we'd also get that. And that's actually probably easier in this case. I don't know. I don't really like decimals. And that's why I'm going to great lengths to avoid them. So should we do a scatter plot? I mean, I'm telling you should, so let's do it. So we're going to go 3.125. Let's just do tick marks here. Okay, so 3.125, we're at 2, which is the maximum. And then it's intercept and minimum. This is definitely not drawn to scale, but I would say I tried, but you watched. I definitely did not. So here, this is good. I think we got this. All right, so the period is 5/2. So 2 pi over b is 5/2, which means 4 pi over 5 is equal to b, right? Like you multiply both sides by b, then multiply both sides by 2/5. So 4 pi over 5 is equal to b. Crazy value of b, but not really a problem. So if we start at x equals 3.125, we're starting at a maximum, so it's positive cosine. So we're going to get, oh, I never figured out the amplitude. So the amplitude, I'm going to do the distance from, well, it's 2.5. I mean, you can work it out however you want. You could do maximum minus minimum divided by 2. That's probably the easiest thing. So 2 minus negative 3 is 5 divided by 2, 2.5. So we'll say f of x is 2.5 cosine of 4 pi over 5, and then x minus 3.125, and then minus 0.5. Gross. All right, what's the next one here? 3.75. Yep, 3.75. All right, so think about it. You started at positive cosine. So you went maximum intercept. Now you're going to go intercept minimum, so negative sine. F of x is negative 2.5 sine. I tend to like move my arms around a lot when I'm working these things out, and I think it helps a lot. Like, I mean, I'm visualizing while I do it, but also I'm physically doing it, which kind of, helpful. 4.375, taking the lazy way out, not adding them. All right, so a negative sine graph goes intercept minimum, so the next one's going to start at a minimum, so it's negative cosine. Negative 2.5 cosine 4 pi over 5. So like sometimes I think it'd be faster if I memorized more things, but like not more satisfying. And so like I want to also enjoy what I'm doing. So, I like to think it through. So the next one is, I don't remember what I'm adding even anymore. Is it just 5? It is just 5. Woo! 5. All right, f of x. Gonna be, all right, negative cosine. So your minimum intercept, then you're gonna go intercept maximum, that's positive sine. So it'll be 2.5 sine of 4 pi over 5, x minus 5, 5 minus 0.5. And there you go. I am not gonna check those. So I think that they're right. I don't know. Everything we did is on the level. Hopefully we got the numerical values correct. So anyway, let's stop this video here, come back in the next one where we will probably be starting note 6. I mean, we're definitely gonna be starting note 6. So print some new notes or get some new paper or whatever, and I will see you there.